Hello, my name is Fernanda Sobral and today I'm going to solve quiz number 1 from the course of Physics 2. So the instruction says, mercury is poured into a U-tube as shown in figure A. I will show you figure A right here. So here we can see it. The left arm of the tube has cross-sectional area A1 of 10 square centimeters, and the right arm has a cross-sectional area A2 of 5 square centimeters. 100 grams of water are then poured into the right arm as shown in figure B. Well, which we can see here next to figure 1, which is this one right here. So it has two parts. First one says, determine the length of the water column in the right arm of the U-tube. So I already draw a similar drawing here. So as we can see, this here forms a cylinder, and the volume of this cylinder is 100 cubic centimeters, because as we know, the density of water is 1 gram per cubic centimeter. So these values should be equal. The same number of grams are the number of cubic centimeters or milliliters that we have in this case. So as we know, the formula for volume should equal the value L, which is what we're trying to figure out, times area 2, which is, as we know, the formula for a cylinder, the area of the base times the height of the cylinder. So in this case, is what we have here. This is the base and this is the height. So if we know that the volume is 100 and we want to find the value of L, we just simply have to bring L to this side, or divide 100 by 5, and we get that the value of L equals 20 centimeters. So that is the first part of our problem in this case. So the next part says, given that the density of mercury is 13.6 grams per cubic centimeter, what distance h does the mercury rise in the left arm? So what we're trying to figure out is this. Once the water is added, how many centimeters does it make mercury go up? So as we know, the volume that is transferred here should be equal to the one right here, because it is a difference between what is happening here and what is happening here. So first of all, what we know are these volumes, right? So there is a relationship with the areas. So we know that the volume here should equal area 1 times h, which I already marked here, which should be equal to area 2, which is this one right here, times, and we will assign a value to this, which is h2. So we name it h2, okay? So this is the first part. The second part is that we set certain points to compare. So we need points at which pressure is the same in order to compare what happens here with what happens here. So we're going to take point 1 as here where h starts, where the pressure should be equal in this side. So we take point 1. And point 2 is going to be right on the surface of both liquids, where the pressure is the same. Because as it is a very small tube and it's a matter only of centimeters, the change in the pressure of the air must not be considered. So in this case, we know we can use Archimedes' equation, Archimedes' law, to figure out that on this side, P1 minus P2 must equal the density times GH. Okay, so this is applicable for both sides. In this case right here, we have P1 minus P2 on the right side should equal the density of the fluid, which in this case is water, times the gravity times h, which in this case the distance here is L, which we already calculated. And in this other case, P1 minus P2 should equal the density, but this time of mercury, which is, chemical symbol is this, times gravity times this difference right here, which is H plus H2, which is marked by these lines, right? So H plus H2. But from this, we know that H2 equals H1 times H divided by H2. So as we know that the pressure here is equal to this one, and the pressure here is equal to this one, we can infer that these two should be equal as well. So when we join these two equations, we have that the density of water times L, because as gravity is in both, there's no need to consider it, equals the density, well, this looks like a P, but it's a rho, of mercury times H times 1 plus A1 divided by A2, which is what I just stated before. So we end up having something like this. I'm going to continue here. H should equal the density of water times L divided by the density of mercury times 1 plus A1 divided by A2. So if we substitute here, we know that this value equals 1, as we're using centimeters and grams. This value equals 20, as we calculated it before. This value equals 13.6, as the problem states. And these values equal 10 and 5. So after substituting all of these, our final answer should be 0.490 centimeters, which is the distance h that mercury goes up once the water is added. And that's all for this problem. Thank you.